What the hell am I doing here? I don't remember the moment I first became conscious, but that must have been the moment in which I first came to exist in the universe. The baby Jesse had been born in Hillsdale, Michigan, and had existed in the material world for some period of time, but I was not him. And I am not him now. I am his mind. His brain developed to some critical degree of connectivity that I, one day, at last emerged in accordance with its processing. Until that day, young Jesse was effectively a zombie creature. I didn't come into this world by birth. I wasn't born. I was conjured. The life of a human being is a weird affair. Once I came into being, the human animal, Jesse Winters of Hillsdale, Michigan, USA, circa early 1980s, is now my problem. That is to say, his problems are my problems. He requires sustenance, so I suffer pangs of hunger. There is something or someone in his vicinity that we don't recognize, so I am terrified. He is crying. I am sad. He is laughing. I am amused. Our little collaboration serves the purposes of this human organism. Am I his slave in the world of mind stuff, or is he my avatar in the world of physical stuff? Both and neither. In his podcast, Sam Harris often instructs us to notice that the objects of our thought and feeling, just like sounds in the environment, simply appear in consciousness. But I argued in the third episode of the podcast that consciousness must have a function. This implies that the mind has some degree of control over what happens next. Remember, in my fifth starting assumption, I claim that consciousness arises from its substrate by physical means. There is only the material universe, but I, a conscious mind, have a special point of view from which to comprehend and interact with the rest of the universe. So how am I manifest in this universe? When Jesse awakes from a dreamless sleep, how does his brain produce me? Narrowing our focus to that critical part of the thalamocortical system has limited the substrate of consciousness toward discovery of the NCC, but we are not always conscious. As a conscious mind myself, I can attest that I do not always exist. I exist when I am awake or dreaming. I cease to exist when when this human organism is in a non-dreaming state of sleep, or when it is under general anesthesia. As I shared with you previously, Descartes said, quote, I am, I exist, this is certain, but how often? As often as I think. For perhaps it would even happen if I should wholly cease to think that I should at the same time altogether cease to be. Unquote. It is rather like time travel from the subjective point of view. Often a substantial number of hours have elapsed in the objective world, but I have simply skipped from conscious epoch to conscious epoch, the stream of my subjective timeline essentially undisturbed. I suppose that the episode of transition from one conscious period to the next is something like a waterfall in the stream of consciousness. This is especially true for the experience of undergoing general anesthesia. You are awake and entering the surgical arena. You are treated with a powerful anesthetic drug. Down the waterfall you go, and an instant later you land in the whirl of returning consciousness at the bottom of the stream. Subsequently, and to your curiosity, you learn that several hours have elapsed in your absence. By contrasting the neuronal network activities that occur in the thalamocortical system during periods of consciousness to those during periods of non-consciousness, we can yield further clues as to what functions are necessary and sufficient for the production of consciousness. In the previous episode, I likened the enabling factors of the reticular activating system in the brainstem to a battery. This analogy is quite imperfect. Recall that the reticular activating system is composed of neurons that broadly target the forebrain and utilize neurotransmitters including acetylcholine and norepinephrine. These neurotransmitters change the firing patterns and capabilities of the thalamocortical networks, enabling conscious states to occur, but they are not acting in the way a battery does. The battery analogy suggests that the state of non-consciousness in the thalamocortical system should be a persistent reduction or cessation of firing activity. In fact, The pattern of firing activity is what changes under the influence of the reticular activating system, not the amount of firing activity. Marcello, Massimini, and Giulio Tononi discuss the differences between consciousness and non-consciousness in their book, Sizing Up Consciousness. They write, quote, "The neurons of the sleeping brain are constantly on the move, so the question is, why does consciousness fade during non-REM sleep, even when neural activity does not? Why is it that when we wake someone from deep non-REM sleep, especially early in the night, and ask them to report anything that was going through their mind just before waking up, they will often say that they were not there. They were coming out of nowhere, out of nothingness, as if I didn't exist. As we said before, this fading of consciousness that dwindles into oblivion, is not accompanied by a commensurate decline in neural activity. There is a difference in how the neurons fire, certainly. The most significant difference seems to be that during non-REM sleep, the sequences of impulses emitted by the neurons become intermittent," unquote. What occurs in the firing behavior of neurons during non-conscious states is that the more often they fire action potentials, the more likely they are to shift into a quiescent period in which they cease to fire. This results in a kind of bistability between up states of firing and down states of silence. Importantly, this firing pattern is not a matter of being asleep versus being awake. It specifically tracks with states of non-consciousness. For when we are dreaming, the thalamocortical activity appears much more like when we are awake. This is critical for our elucidation of the substrate of consciousness, because when we are dreaming, we are quite conscious. When we speak of neuronal firing behavior, we are of course speaking of action potentials. These signals are the currency of the nervous system economy. There are many subtypes of neurons, but the basic morphology consists of a cell body, or soma, with several incoming branch-like dendrites and one outgoing axon, which normally branches along its way to a number of other target neurons. Synapses are formed between the tip of the axon and a dendrite on the target neuron. Typical neurons in the forebrain are either excitatory or inhibitory. When an excitatory neuron fires an action potential, vesicles at the presynaptic side of its axon tips fuse with the synaptic membrane and release glutamate, the major excitatory neurotransmitter in the brain. Glutamate activates receptors on the postsynaptic side, that is, a dendrite of a target neuron. This results in a local depolarization of the target neuron cell membrane. Generally, the dendrites are receiving such synaptic communications from many axons from many neurons. If enough depolarization occurs in the membrane of the target neuron to achieve a threshold at its soma, it will fire one or more action potentials of its own. In the case of an inhibitory neuron firing an action potential, vesicles on the presynaptic side of its axon tips will release GABA. Receptors for GABA on the dendritic side of the synapse will receive that signal and cause the hyperpolarization of the target neuron cell membrane. This is the opposite of depolarization, and it acts to prevent the target neuron from achieving its threshold. If at any time the neuron achieves its threshold potential, it will fire one or more action potentials. These action potentials are the capacity to exhibit causality on the production of action potentials by downstream neurons. The more synapses that a neuron makes with its target, and the stronger those synapses are, the more causality the action potentials in the first neuron have on the production of action potentials in the second neuron. In the thalamocortical system, our substrate of conscious experience is highly and reciprocally integrated. This means that the firing of action potentials by one neuron, or one group of neurons, can have causality that spreads far and wide across the network and even returns to the original neuron to exhibit causality on its future self. Action potentials are dependent on voltage-gated sodium channels. Remember, I told you that during graduate school I was investigating a mouse with a genetic mutation of one of the subunits of the voltage-gated sodium channel. I told you that the animals had severe epilepsy. Now you can understand why that might occur. Epilepsy is a condition in which the patient has recurrent seizures, which are out-of-control synchronized firing activities that spread through the brain's networks. It's worth noting that during severe seizures, there tends to be a loss of consciousness in the patient. EEG, electroencephalography, is a means of recording the regional firing activities of cortical neurons. The brain waves that we see in these recordings are simply the sum of the activity of thousands of neurons in the vicinity of the electrode. So we do not see individual firing events over time using EEG. Rather, we see the overall activity for that area of the network. This provides good temporal resolution, but lousy spatial resolution. EEG can be used to differentiate between waking states, REM sleep, and non-REM sleep quite easily. During non-REM sleep, in which we expect the subject to not be conscious, the EEG shows large, relatively synchronous slow wave activity. This means that large amounts of neurons are firing during the same time period and then falling into down states for the same time period. The sum of all that looks like high amplitude, slow waveforms. During waking and REM, we see highly asynchronous firing. Because the neurons are not all firing together during up states and then shutting off into down states, the amplitude of their total activity is low, with busy ups and downs reflecting all of the neurons in the vicinity of the electrode doing their own thing. The difference evident in the EEG between conscious and non-conscious states reflects an important point. During non-consciousness, when the network is largely synchronized, there is little capacity for differentiation. That is, in order for the cortex to produce specific conscious contents, the relevant neurons carrying signals that it has received from, say, the primary visual cortex, V1, the neurons must be able to express themselves freely in accordance with the stimuli they are receiving. These neurons here, responding to some stimulus, must be able to fire action potentials without those neurons over there, which have no such stimulus, joining in. Every possible combination of incoming stimuli and internal communications that produces every possible conscious experience with all its specificity of qualia is differentiated from every other combination that there might be. Now that we have reviewed the means by which neurons communicate using action potentials, I want to share with you some critical experimental evidence for what happens in the thalamocortical system during states of consciousness, but not during states of non-consciousness. These experiments were led by Marcello Massimini. His group used a technique called transcranial magnetic stimulation, or TMS, to externally stimulate a small region of cortex while they measured EEG using electrodes situated across the cortex. Massimini and Tononi describe the experimental approach in their book, Sizing Up Consciousness. They write, quote, "The idea is very simple, at least on paper. First, knock on the cerebral cortex with TMS and then listen to the brain's echo with EEG. TMS turns on a group of cortical neurons which react by generating electrical impulses impacting upon other cortical neurons and so on, finally triggering a chain reaction that resonates within the entire system. By applying a large number of electrodes to the patient's scalp and connecting them to a special TMS-compatible EEG amplifier, it is possible to pick up the echo of the rush of electrical activation throughout the brain with millisecond precision. The more the brain is integrated and differentiated, the more global and complex will be the causal chain of electrical events triggered by TMS." Unquote. Massimini and his colleagues applied this technique to human subjects during waking states and different states of sleep. Massimini and Tononi write, quote, "When everything was ready, we asked the student to stay awake, and using neuronavigation, we targeted the TMS probe and set it to the right intensity to activate cortical neurons. We turned on the stimulator, which started pinging the cortex regularly, once every 2 seconds or so, and we took our place in front of the monitor to appreciate the brain's electrical echo. The first measurement met our expectations. The initial activity, triggered by the magnetic perturbation in the site immediately below the stimulator, shifted from one cortical area to another, reverberating for approximately 300 milliseconds. The end result was a complex chain of causal interactions in which many areas distributed across the cortex lit up and shut down in different ways and at different times. We declared ourselves satisfied. We had knocked on the waking brain and had recorded the distant echo of diversity and unity. Then we turned off the lights and told the student to try to catch some sleep. After about 20 minutes, we were ready to probe, for the first time, a brain caught in the large waves of deep, non-REM sleep. we switched on the TMS again and aimed it at the coordinates of the same group of neurons that we had stimulated before, releasing the exact same magnetic field. We stared at the computer monitor, glooming in the dark, and after a few pulses of TMS, the response of the sleeping brain was already clearly visible. The area just below the stimulator bounced with a positive-negative wave of electrical activity, which was obviously larger than the response recorded in wakefulness. However, the electrical symphony had gone. It was almost as if the coarse physical composition of the brain had changed. The multiform echo that resounded through the entire cranium had given way to a dull thud. The initial response was large, but did not propagate beyond the area that was being directly stimulated, and the cerebral cortex seemed fragmented. We shook the student awake and asked him what he was feeling, what he remembered of what was going on in his mind. The response? A laconic nothing, as if he had not been there." Unquote. This experiment was transformational in my thinking about the problem of consciousness. I apologize to Marcello and Giulio for quoting them at such length, but this work makes them heroes of mine. Gentlemen, you are steely-eyed missile men. They tried the TMS EEG experiment in patients under general anesthesia and saw the same lack of complex differentiation. During REM sleep, the result looked like it had during waking, with a complex response in the EEG. Thus, a major breakthrough in elucidating the NCC had been accomplished. The combination of discovering the brain regions underlying states of consciousness and the brain activities that those regions must be engaged in is narrowing the focus for the neuroscience of consciousness. We have learned a lot from this approach. I have now, I believe, provided enough necessary background information to share with you in the next episode of the podcast my own theoretical framework for consciousness. There is a line of thought that haunts me from time to time. It occurs to me an area of doubt that even Descartes, that great doubter, appears not to have considered. When he says, quote, "I am, I exist, but how often?" unquote, he presupposes that it is he who has existed before in each instance of his waking consciousness. If I am the mind of a particular human animal, the mind of Jesse Winters, how do I know that I was ever his mind before now? Accepting that conscious experience is continuous until we fall into a dreamless sleep, I can justify the claim that I who end this episode am the same being that began it. But was it I that presented episode 4? I certainly remember having written and recorded it. Perhaps, though, I am a newborn entity since my waking today, and this organism, Jesse, produces a similar but not identical conscious being each time he wakes. Consider briefly the thought experiment of a teleportation machine. In The Emperor's New Mind, Roger Penrose writes, quote, "Instead of being physically transported by a spaceship in the normal way, the would-be traveler is scanned from head to toe, the accurate location and complete specification of every atom and every electron in his body being recorded in full detail. All this information is then beamed at the speed of light by an electromagnetic signal to the distant planet of intended destination. There, the information is collected and used as the instruction to assemble a precise duplicate of the traveler, together with all his memories, his intentions, his hopes, and his deepest feelings." Unquote. If I were to enter this machine and immediately be destroyed, as per protocol, thus ceasing to exist here on Earth, who would be Jesse's mind on that other planet? If I am the mind that emerges from that precise configuration of thalamocortical activity, then I should happily appear as the point of view of the new and distant Jesse. For me, it would be no different than falling unconscious here and waking up over there. But what if proper protocol is not followed according to the teleportation standard operations manual? What if Jesse here is not destroyed immediately upon the scanning and sending of all that information to the destination planet? Can I, a single mind, exist in two places? If not, then perhaps the new and distant Jesse has conjured a new mind. And if he can do that, then how do I justify the belief that I have ever existed before today? Why can't this human animal produce a new mind with every epoch of its conscious life? How can I be confident that Jesse hasn't been doing this all along?